Important questions. Question number 1. X power 4 minus x whole power 1 by 4 divided by x power 5 dx. Here we can take out x power 4. So this will become x power 4, then this will become 1 minus this will become 1 upon x cube and whole power 1 by 4 dx divided by x power 5. X power 4 power 1 by 4 will give x, and here this will become 1 minus 1 upon x cube 1 by 4 dx divided by x power 5. 1x will cancel out from here, so we will get 1 minus 1 upon x cube power 1 by 4 dx divided by x power 4. Now let 1 minus 1 upon x cube equal to t. This will give 3 upon x power 4 dx equal to dt, which implies dx upon x power 4 is equal to 1 by 3 dt. So 1 by 3 t power 1 by 4 dt equal to 1 by 3 t power 5 by 4 divided by 5 by 4. It would be 4 upon 15 and t is 1 minus 1 upon x cube, 1 minus 1 upon x cube power 5 by 4 plus c, which is our answer. Now let's go to next question. X square, sorry, x power 4 dx divided by x minus 1 and x square plus 1. So here power of numerator is larger than the product of maximum power of denominator. So if we multiply denominator x minus 1 times x square plus 1, so we will get x cube minus x square plus x minus 1. So highest power in denominator is 3, whereas highest power in numerator is 4. So we must divide. So x power 4, x cube minus x square plus x minus 1. So x times it will give x power 4 minus x cube plus x square minus x. Changing sign, x cube minus x square plus x. So 1 times x cube minus x square plus x minus 1. Minus plus minus plus. So remainder will be 1. So our question will be integration of x plus 1 dx plus integration of remainder 1. So we can write dx divided by x minus 1 and x squared plus 1. Here we have to use partial fractions. So we write 1 upon x minus 1 times x squared plus 1 equal to a upon x minus 1 plus bx plus c upon x squared plus 1, which will give 1 equal to a times x squared plus 1 plus bx plus c times x minus 1. Now we put x equal to 1. Let x equal to 1. In that case, this term will become 0 and we will get a equal to half. Then we take x equal to 0. When we take x equal to 0, then 1 equal to a plus c minus 1. That is a minus c equal to 1, but a equal to half. So minus c equal to 1 minus half. So that will give c equal to minus half. So we have got c equal to minus half. Now we take x equal to 2, and then we will get b equal to minus half. So we have got all values. So our question will become integration x plus 1 dx plus value of a, that is 1 by 2 integration dx upon x minus 1 plus value of b, that is minus half x dx divided by x square plus 1 plus value of c, that's minus half integration dx upon x square plus 1. Now we can easily integrate. So here integration of x plus 1 will give x square by 2 plus x plus, this will become 1 by 2 log of x minus 1. And here we can take x square plus 1 equal to t and 2x dx equal to dt. That will give x dx equal to 1 by 2 dt. So this will become minus 1 by 4 log of x square plus 1 and minus 1 by 2. This is formula of tan inverse x. So tan inverse x plus c. Let's go to next question. This very important question for school tests or board exam. So you must practice it. So let's see. Here we have to take out root tan x. So if we take out root tan x, then 1 plus, it will become root cot x upon root tan x dx. This can be written as root of tan x times 1 plus cot x dx. Now let tan x equal to t square. So it will become sec square x dx equal to 2t dt. But sec square x equal to 1 plus tan square x equal to 2t dt, and tan x equal to t square, so it will become 1 plus t power 4 dx equal to 2t dt. So dx will be equal to 2t upon 1 plus t power 4 dt. So if we put these values here, so our integration will become integration tan x equal to t square, so this will give t, and 1 plus cot x. If tan x equal to t square, then cot x must be 1 upon t square into dx is 2t dt divided by 1 plus t power 4. So here this 2t and t will become 2t square. So 2 outside, t square into 1 plus 1 upon t square dt divided by 1 plus t power 4. Now this t square can be written as 1 upon t square in denominator. So we can write it further twice of integration 1 plus 1 upon t square dt divided by, when this t 1 upon t square 1 upon t square times 1 plus t power 4, we rearrange it, it becomes 1 plus 1 upon t square dt divided by, when this t square goes inside, it will become 1 upon t square plus t square. Now we write it further. So it becomes I equal to twice of integration 1 plus 1 upon t square dt divided by t square plus 1 upon t square. And if you remember, t minus 1 upon t whole square formula a minus b whole square equal to, here it will become t square plus 1 upon t square minus twice of t into 1 upon t will give 2. We have t square plus 1 upon t square this term, so we can shift this 2 to LHS. So we will get t square plus 1 upon t square equal to t minus 1 upon t whole square plus 2. So we write it twice of integration 1 plus 1 upon t square dt divided by t minus 1 upon t whole square plus 2. Now further, so let 1 minus, sorry, t minus 1 upon t equal to u. This will give 1 plus 1 upon t square dt equal to du. So our question will become twice of integration du upon u square plus 2, which is twice of du upon u square plus root 2 square, which can be written as this formula integration dx upon x square plus a square equal to 1 upon a tan inverse x upon a. So twice of 1 upon a means 1 upon root 2 tan inverse u upon root 2 plus c. Now going back, so this will become root 2 tan inverse t minus 1 upon t divided by root 2 plus c, which can be further simplified. So it will become, let's write the value of t. We have taken tan x equal to t square. It means t will be equal to root tan x. So I will be equal to root 2 times tan inverse. This will be t square minus 1 upon t times root 2 plus c. So root 2 tan inverse tan x minus 1 upon root 2 tan x plus c, which is our answer. Let's go to next question. Question number 4. Limit minus 1 to 3 by 2 integration modulus x sine pi x. Here, this function can be written as fx equal to modulus x sine pi x, which will become x sine pi x in interval minus 1 is less than x is less than 1. And it will become minus x sine pi x when interval is 1 to 3 by 2. So we can break this integral into parts. So I equal to integration minus 1 to 1 x sine pi x dx, then minus sign x sine pi x dx, limit is 1 to 3 by 2. Now let's integrate anyone because both are same and then we will put the limits. So integration of x sine pi x dx can be found by using Eilert rule. So here sine pi x will be integrable function. So x times this will become minus cos pi x upon pi minus x will be differentiated, that will give 1. So minus cos pi x dx divided by pi. So finally we will get minus x cos pi x upon pi plus here it will become integration of cos pi x will give sine pi x upon pi. So it will become 1 upon pi square sine pi x. So we can put the limits for both the integrals. So I'm deleting this portion and we will write it. This portion will become minus x cos pi x upon pi limits minus 1 to 1 minus x cos pi x upon pi plus 1 upon pi square sine pi x. Sorry. We must write complete integral for first. So this is plus 1 upon pi square sine pi x and its limit is minus 1 to plus 1. And then second one, minus sign outside. Again, we have to copy this x cos pi x divided by pi plus 1 upon pi square sine pi x limits 1 to 3 by 2. Now we can easily put the limits, keeping in mind some facts like cos pi is minus 1, cos minus pi will also give minus 1, sine pi will become 0, and sine of minus pi will become 0. Then we will get cos 3 pi by 2 and sine 3 pi by 2. So for these values, we can recall the graph. For sine x, it's like this. This value is pi by 2. This is pi. This is 3 pi by 2. So at 3 pi by 2, sine becomes minus 1. So cos will become 0 at that value, because wherever sine is maximum, cos will be minimum. And then we can easily evaluate, and after evaluation we will get 3 upon pi plus 1 upon pi square. Now let's go to next question, question number 5. So here, suppose this is I and suppose this is equation number 1. We are going to use the property 0 to a fx dx equal to 0 to a f a minus x dx. So this can be written as I 0 to pi, and this will become pi minus x dx divided by a square cos square x plus b square sine square x. Suppose this is equation number 2. On adding 1 and 2, we will get 2i equal to 0 to pi. Since denominators are same, so a square cos square x plus b square sine square x, and in numerator we will get x plus pi minus x dx. So x will cancel out and we will get 2i, sorry, 2i equals pi times 0 to pi dx divided by a square cos square x plus b square sine square x, sine square x. We can write I equal to pi upon 2 integration 0 to pi dx upon a square cos square x plus b square sine square x. Now again, we are going to apply property 0 to a fx dx equal to, so this is 0 to 2a. So twice of 0 to a fx dx when function is even. So here it will become I equal to pi by 2 into 2 times 0 to pi by 2 dx upon a square cos square x plus b square sine square x. Now further, it will become I equals pi times integration 0 to pi by 2 dx upon a square cos square x plus b square sine square x. We multiply each term by by sec square x, or we divide each term by cos square x. So when dx is divided by cos square x, it will give sec square x dx, and this will get cancelled and this will become tan square x. So pi times 0 to pi by 2 sec square x dx divided by a square plus b square tan square x. Further, it will become, let's take b tan x equal to t, b sec square x dx equal to dt, or sec square x dx equal to dt by b. So this will become pi upon b times integration dt upon a square plus t square. Now we can change the limits, or if we don't want to change the limits, then we have to carry this. So let's not change 0 to pi by 2. Now it will become pi upon b. Here this is formula integration dx upon x square plus a square equal to 1 upon a tan inverse x upon a. So this will become 1 upon a tan inverse t upon a, but t equal to b tan x. So we write it limits 0 to pi by 2. So pi upon ab tan inverse, in place of t we write pi by 2. So pi by 2 times 1 upon a minus tan inverse 0. So tan inverse pi by 2. Sorry, here there is one mistake. Before putting the limit, we must put the value of t, as we have not changed the limit. So it will become tan inverse, in place of t, let's write b tan x upon a. And then we must put the limits. So it will become I equal to pi upon ab tan inverse. And when we put pi by 2, tan pi by 2 is infinity. So this will become tan inverse. This is infinity minus, when we put 0, So we will get tan inverse 0. But tan inverse infinity means pi by 2. So pi upon AB times pi by 2 minus tan inverse 0 is 0. So we get pi square upon 2AB, which is our answer. Thank you for watching.